Have you ever wondered how a single can of Sting energy drink is actually made inside one of the largest beverage factories in China? From the outside, it looks like just another modern factory, but inside, it is a non-stop machine built to produce millions of cans every single day. This is not a place where drinks are simply mixed and packaged, but a high-speed system where every second, every gram, and every movement matters. Deep inside this factory, a familiar product begins its journey through a tightly controlled process designed for speed, accuracy, hygiene, and perfect consistency. And the story of each can does not begin on the filling line, but much earlier, with the careful arrival and inspection of raw materials. A can of Sting may look simple in your hand, but inside it is a formula made from purified water, sweeteners, caffeine, taurine, vitamins, acids, and flavor compounds. Each ingredient has a specific role, from creating sweetness and acidity to delivering the sharp flavor and energy effect consumers expect from every can. But before anything can be mixed, every raw material must pass strict incoming quality checks to confirm purity, safety, and consistency. Even the water used in production is not ordinary water, because it must be purified and stabilized to meet exact beverage manufacturing standards. It passes through multiple filtration stages, mineral adjustment, sterilization, and microbiological control before it is allowed anywhere near the mixing tanks. At this scale, one small impurity could affect thousands of liters, which is why nothing enters the process without verification. Once the ingredients are approved, they are transferred into secure storage systems designed to protect them from moisture, contamination, and measurement errors. Here, nothing is handled casually, because every batch must taste the same whether it is produced today, tomorrow, or months from now. The next stage is where the formula truly begins to come alive, inside a mixing area dominated by giant stainless steel tanks and automated dosing systems. This is where purified water, sweeteners, acids, caffeine, taurine, and flavor bases are combined according to a tightly protected formulation. No worker stands here pouring ingredients by hand, because the entire dosing process is controlled by computers programmed for exact precision. At this stage, even a very small deviation in sweetness, acidity, or caffeine concentration could change the taste and performance of the final drink. That is why the system measures ingredients by weight, flow rate, and concentration, then constantly compares them against the approved target formula. Once loaded into the tank, the ingredients are blended at high speed so that the mixture becomes completely uniform before the next stage begins. Powerful agitators spin inside the vessel, breaking up concentrated zones and ensuring the flavor profile is evenly distributed throughout the batch. Samples are taken again during mixing to confirm the batch matches the exact flavor, pH, and sugar profile required by the factory standard. If something is slightly off, the system can still make adjustments before the liquid moves forward, preventing an entire production run from being wasted. Only when the batch reaches the approved standard is it released from the mixing zone and sent deeper into the production system. But Sting is not just a sweet liquid, because one of its defining features is the sharp, sparkling sensation created by dissolved carbon dioxide. That means the next step is carbonation, a carefully controlled process that gives the drink its pressure, texture, and signature bite. Carbon dioxide cannot simply be pushed into the liquid carelessly, because temperature, pressure, and timing must be balanced with high precision. The liquid is chilled to a low temperature first, making it easier for carbon dioxide to dissolve properly into the beverage. Then the gas is introduced under pressure so it binds evenly throughout the liquid instead of escaping too early. If the pressure is wrong, the drink may lose its signature feel, and if the temperature rises too high, carbonation can become unstable. So at this stage, sensors continuously track dissolved gas levels to ensure the same sparkling profile in every batch. While the drink itself is being prepared, another part of the factory is already producing the containers that will hold it. This is the can manufacturing section, where giant coils of aluminum are transformed into lightweight containers at astonishing speed. Each coil contains an immense amount of metal, and from that single roll, thousands upon thousands of cans can be created. The process begins with cutting metal blanks from the sheet, creating round discs that will become the foundation of each can body. Those discs are then pushed through, forming stages that stretch and shape the metal into tall, seamless, cylindrical containers. What looks simple from the outside is actually a carefully engineered process that must protect strength while keeping the walls extremely thin. If the can wall becomes too thin, it may fail later under pressure, but if it is too thick, material costs rise dramatically. That is why the forming line is calibrated with extreme care, using pressure, speed, and tool geometry tuned to exact specifications. The newly formed cans then move to trimming, where their height is standardized so that every container matches the same production dimensions. Even slight differences here could create filling and sealing problems later, so uniformity is essential from the very beginning. After shaping, the cans are thoroughly washed to remove lubricants, microscopic particles, and any residue left from metal forming. This cleaning stage is critical because no residue from the metalworking process can remain inside a food-grade container. Once cleaned, the cans pass through drying systems that remove moisture before the next stage of treatment and decoration. At this point, the can is still only bare metal, but soon it will become the branded package recognized by consumers everywhere. The next area is where the factory transforms those empty silver shells into instantly recognizable Sting cans through color, text, and graphics. High-speed printing systems apply the exterior design with careful registration so that every logo and every line sits in exactly the right position. The rich colors, metallic shine, and protective outer finish all need to look sharp and consistent, even when produced at incredible speed. If the print is blurred, off-center, scratched, or faded, the can will not continue down the line. Because in a factory of this size, appearance is not treated as something optional, but as part of the product standard itself. Before filling begins, the cans are checked again for dents, deformities, and surface damage that could affect later sealing or transport. Only after the liquid is ready and the cans are approved can both streams finally meet at the filling line. This is one of the most important parts of the entire factory, because here, speed and precision must work together without interruption. Empty cans are fed into the line in perfect order, guided by rails and conveyor systems designed to move them without collisions or delay. At this speed, even a small jam could interrupt the entire process, so flow control on the line is constantly monitored. The filling system then injects the carbonated beverage into each can with astonishing accuracy, measured down to tiny fractions of a milliliter. Filling too little would disappoint the customer, while filling too much could cause pressure, sealing, and packaging problems later. That is why the machine continuously adjusts its performance to compensate for speed changes, temperature shifts, and line pressure variations. The cans never stop moving for long, because this factory is built for uninterrupted flow from one station to the next. Once filled, each can must immediately move to sealing before carbonation escapes and product integrity is compromised. This next step may look simple from the outside, but sealing a carbonated can is one of the most important operations in the entire process. Aluminum lids are fed into the line at high speed, synchronized precisely so that each filled can receive a lid at the exact right moment. The seaming machine then folds and compresses the lid onto the can body, creating an airtight seal strong enough to hold internal pressure. If this seam is even slightly defective, the can may leak, lose gas, or fail during transport, which makes seam quality absolutely critical. That is why the line does not simply trust the machine, but verifies seam dimensions and seal performance again and again. With the can now sealed, it finally becomes the finished product shape that consumers recognize on store shelves. But the factory still does not consider the can ready, because now it must prove that it can meet strict quality standards. First, machine vision systems inspect the outside of every can, searching for dents, scratches, misprints, and damaged lids. These cameras work far faster than the human eye, capturing subtle defects that would be easy to miss at full production speed. The line also weighs the cans to confirm that the correct amount of beverage was filled into each one. A can that is underfilled, overfilled, or otherwise outside specification is automatically removed before it can continue. Pressure integrity tests are also performed to confirm that carbonation is being contained properly inside the sealed container. If a can loses pressure too early, the consumer experience changes completely, and the product no longer meets its intended standard. Some samples are also opened and analyzed in the lab to confirm taste, carbonation, acidity, and chemical balance. This means that quality control is not just something added at the end, but something woven into every stage of production. Only after a can survives all these checks can it move on to packaging, where individual units become retail-ready products. In the packaging hall, the pace remains just as intense because the factory must organize enormous volumes without breaking the flow. The cans are first sorted into specific pack sizes depending on the market format required for distribution. Some are prepared as smaller retail packs, while others are directed toward larger carton cases intended for wholesale and logistics channels. Wrapping systems then apply film or carton structures that hold the cans tightly together while protecting them during transport. Heat tunnels or sealing systems secure those packs so they remain stable through handling, shipping, and storage. Larger case packing machines take over for bulk output, stacking multiple units into transport-ready cartons with precise mechanical timing. Every package must be counted correctly, aligned properly, and sealed securely before it can move further down the line. Product coding systems also print essential information such as batch numbers, manufacturing dates, and traceability data onto the packages. This information may look small and ordinary, but it allows the factory to track the exact history of every batch it produces. Once packed, the finished units move toward palletizing, where the factory prepares them for storage and shipment on a much larger scale. Here, robots often take over, stacking cases with speed and precision that would be difficult to match manually. The layers must be arranged carefully, so the load remains stable during storage, movement, and long-distance transport. Once stacked, the pallet is often wrapped and secured so that the products can move safely through the supply chain. At this point, the cans that began as raw ingredients and aluminum coils are now fully prepared for mass distribution. But even now, the process is not really over, because the final challenge is moving this enormous output to the market efficiently. Forklifts and automated warehouse systems begin moving finished pallets into staging areas organized by route, destination, and delivery schedule. In a factory producing millions of cans, distribution planning is not a side task, but an essential extension of manufacturing itself. Products must leave the factory in the right sequence, because delays in transport can quickly create pressure on storage and production flow. Loaded trucks carry the product out toward distribution centers, retail chains, wholesalers, and countless points of sale across the market. What seems like a simple drink on a store shelf is actually the result of a complex industrial network working with incredible coordination. And behind that network stands a factory that rarely sleeps, because production at this scale depends on continuous operation. This is a 2-4-hour manufacturing environment where machines, sensors, operators, and technicians work in rotating cycles around the clock. Because shutting down a line like this is never a small decision, and restarting it can cost both time and money. So maintenance teams work proactively, inspecting equipment before major failures can happen, and keeping the system stable under constant demand. Every pump, conveyor, filler, seamer, and sensor becomes part of a giant machine that must keep working together without losing rhythm. To achieve that, the factory depends heavily on automation, with real-time data collected from almost every important point in the process. Temperatures, pressures, flow rates, fill levels, line speed, seam quality, and output counts are all tracked continuously. If one value begins drifting outside its acceptable range, alerts can be triggered before the problem spreads through the line. This kind of data-driven control helps the factory protect both quality and output, even under the pressure of non-stop production. But automation alone is not enough, because human expertise still plays a critical role in keeping such a system reliable. Engineers analyze performance, technicians respond to equipment behavior, and supervisors coordinate production targets with strict timing. In a facility this large, success depends not only on machines, but on trained people who understand exactly how the process must behave. Hygiene is another area where nothing can be taken lightly, because a drink factory must maintain strict sanitary conditions at all times. The equipment, pipelines, tanks, and filling systems are cleaned through scheduled sanitation routines designed to protect product safety. These cleaning operations remove residues, control microbial risk, and prepare the system for the next production cycle without compromising standards. Workers also follow strict protective procedures, including uniforms, gloves, hair protection, and controlled movement through sensitive areas. Because even in a highly automated environment, product safety still depends on disciplined human behavior. When all of these systems work together, the result is not just speed, but controlled mass production built on repeatability. That repeatability is what allows consumers to expect the same Sting taste, same carbonation, and same experience again and again. At this scale, consistency is not accidental, but the product of thousands of controlled decisions made every single day. And that may be the most surprising part of all, because the simple can in your hand hides an enormous amount of invisible complexity. From purified water and precise chemistry to engineered cans and robotic packaging, every step exists for a reason. Nothing is added casually, nothing is moved randomly, and nothing is left to guesswork inside a factory like this. Every pathway, every machine setting, and every inspection point is part of a system designed to reduce risk and protect output. That is how a factory can turn raw materials into millions of finished cans without losing control over quality. And yet for most consumers, all of that effort disappears the moment the drink is opened and enjoyed. You hear the crack of the tab, the release of pressure, and the sound feels effortless, even though the process behind it is anything but. In that single moment, the work of engineers, operators, chemists, technicians, and logistics teams finally reaches the customer. And that is what makes modern factory production so fascinating, because everyday products often hide extraordinary systems behind them. In the case of Sting, what looks like a simple beverage is actually the result of chemistry, engineering, automation, packaging, and logistics working as one. That coordination must hold through every hour of the day, every shift of workers, and every batch moving through the line. Because once production reaches this scale, discipline becomes just as important as machinery. And without that discipline, the speed that makes the factory powerful could also become its greatest weakness. So the true story of this factory is not just about volume, but about keeping precision alive inside relentless motion. Millions of cans per day sounds impressive, but the real achievement is producing them while protecting taste, safety, and consistency. From the first filtered drop of water to the final wrapped pallet, every stage adds something essential to the product you eventually see. And when you step back and look at the whole process, it becomes clear that a modern drink factory is a world of its own. It is a place where raw chemistry meets mechanical engineering, where packaging meets logistics, and where scale meets discipline. It is also a reminder that even the most ordinary products often depend on extraordinary levels of planning and control. The next time you see a can on a shelf, it may still look simple, but now you know just how much stands behind it. A single can represents purified materials, exact measurements, high-speed machinery, constant inspection, and a supply chain built for scale. It represents not just manufacturing, but trust, because consumers expect the product inside to be safe, stable, and familiar every time. That trust is earned through routine, testing, maintenance, monitoring, and standards that are repeated day after day without compromise. And in a place like this, compromise is expensive, because even one weak point can affect a huge volume of product very quickly. That is why the factory keeps watching, measuring, cleaning, adjusting, and verifying from the first minute of production to the last. By the time a can finally leaves the plant, it has already passed through a long chain of technical decisions most people never get to see. And that hidden chain of decisions is what makes the modern factory one of the most fascinating places in industrial life. Because inside these walls, ordinary ingredients are transformed by precision into something standardized, scalable, and ready for the world. That is the real power of this factory. Not only its size, but its ability to repeat complexity with discipline every single day. So the next time you open a can of Sting, remember that behind that small moment stands an entire industrial world. A world of purified water, protected formulas, engineered aluminum, automated filling, airtight sealing, and relentless quality control. A world where millions of cans can be made daily, not by accident, but through systems built to control every important detail. And that is what makes this place more than just a factory, because it is really a machine for turning precision into everyday products. If you found this journey inside China's largest Sting energy drink factory fascinating, imagine how many other products hide stories just as extraordinary. If you enjoyed this video, like, subscribe, and tell us which giant factory or production process you want to explore next.